So we are going to discuss about cantilever beam containing UVL, raw SFT and BMP for this loading. So here we have already done the calculation for the reaction at B. The net reaction at B is equal to 12 kilonewton and the load intensity at X is 3 by 2x. And according to this section, we will draw the variation of shear force diagram and bending moment diagram. Before that, we can find the moment B. The moment will be equal to the net moment that is producing on the beam. For this, we will first determine the total load. The total equal to half into base into height and point where the total load is applied. For a triangular loading, we know that the centroid lie at the distance 2L by 3 from the narrow end, and from broader end it is L by 3. So here we multiplied by 12 by 3, therefore 2 into length is equal to 4 meter 4 by 3. Cancel out by 2 to 4 and that 3 plus 6, 4 to the 8 and 8 to the 30. That is equal to 30 kilonewton. After that, we will show the variation of the shear force diagram and bending moment diagram. For the variation of shear force diagram, first shear. The equation of shear force at the section X is equal to, if we see if there is one upward force that is RP and the downward force is the loading that is applied on the beam. So RB is taken as negative because it is on the left side of a section. So take it minus 12 already determined plus the downward loading, that is downward loading half into length into whatever the Wx. Wx is equal to 3 by 2 of 3 by 2 of. From here we can find the equation, that is minus 12 plus 3x square upon 4. This is the equation for the shear force variation. Now at x is equal to 0, we can see that the shear force at point B is equal to minus 12, and at x is equal to 4 meters, the shear force will be equal to 0. Now let us check it by calculation. Minus 12 plus 3 into 4 into 4 divided by 3. So the net summation is equal to the 0. As you also note that at the free end, the shear force is 0. There is no reaction. We can see that the equation is parabolic in nature. Equation is parabolic in nature, so we will keep in mind that when we draw the variation of the shear force diagram, we will take the curvature of parabola. After that, we will calculate for bending moment diagram, BMD. Moment at the section X. For moment at the section X, we will consider the moment that is acting on the support P. We can see from here the moment P acting on the support and the moment generating due to the downward loading. So there are two types of into the P. And reaction R. So we can see from the figure that the moment MB is acting like this, and the reaction is like this, and the downward loading is something like this. Therefore, the effect of MB is hogging. Effect of RB is sagging moment, and the downward loading also produces the hogging effect. And we know that hogging moment is taken as negative and sagging is taken as positive. So here we can write the equation, that is RB into X minus due to the downward loading. For downward loading, we can write it as half into X, and the loading intensity WX is taken as WX is taken as 3 by 2 of 2 of X, and uh, it is applied at a distance of x by 3. X by 3 is taken because the moment is taken along the section XX, and from the broader end, as already discussed, from the broader end, distance is taken as x by 3. So we multiply by x by 3, and the remaining moment is MB. Therefore, minus MB, and the value of MB is minus 12. So let us find the value of mx at the section at the point B, at point B, that is x is equal to 0. At x is equal to 0, we can see that the moment at B is coming as minus 12 kilonewton meter. And for free end, the moment should be 0. If we check it by calculation, for free end, that stick at point A, at point A, x is equal to 4 meter. In the value of x is equal to 4 meter, RB is equal to 12. So 12 into 4 minus 1 by 2 into x into 3 by 2 of x, that is 4 into 4 by 3 minus 12. When we calculate this value comes as 0, and this x is equal to, cancel out if I took the 4. Therefore, and see that 12 4s are 48 minus 16, 48 minus 16 minus. Here by mistake, the value of MB is taken as 12. The value of MB we have find out that is equal to 30. Therefore, it's 32. At 32, therefore net summation is equal to 0. So we can see that the bending moment at point A is 0, and shear force is also 0 at the. After that, we'll draw the variation of shear force and bending moment. This is the required loading given in the question. If the loading intensity is given as 6 kilonewton per meter, here it is 0. This is point B and this is point A. If we draw the SFT, shear force diagram equation is parabolic, and at point B the intensity is minus 12 kilonewton. Therefore, it will like something this 12 kilonewton. And for BMD, it is a cubic equation having value minus 32 at the B. Like parabolic equation, cubic equation is also drawn, and this value is equal to 32 kilonewton. So this is all about the cantilever beam containing uniform varying loading.